Alrighty, let's get us started. I would like to begin today, everybody, by acknowledging the traditional owners of the land where I am today, the land of the Wurundjeri people of the Kulin Nation, and pay respect to elders past and present, and extend that respect to traditional custodians of country throughout Australia. Let me just quickly share my slides with you. We have some of the essential housekeeping business to go through at this point. Firstly, please note we are recording this session and it will be available on the Australasia Preserves YouTube channel after the fact. We do have a code of conduct for the community. Australasia Preserves is a very diverse community from a really wide range of social, cultural, and professional backgrounds. So we do ask that everyone brings a spirit of respect and friendly inquiry to all of our interactions here in these meetings. So if there are any issues, if anything's uncomfortable for you at any point, do not hesitate to get in touch with me or one of the organizers of the Australasia Preserves community. They're all going to say hello in the chat function right now so that you know who they are. Speaking of the chat function, we use this for discussion, for questions. Use it as you like as we go. Introduce yourself, say hello, tell us where you're coming from today. Yeah, it's yours to use. Let me see, what else do we have to do? We should just launch straight into the agenda. Here's what we're doing today, folks. We have 3 amazing speakers from a really wide range of organizations. We are going to hear from Carey Garvie from the National Archives of Australia on some work they're doing at the National Archives to revise their identifier system in order to deal with multiple representations and complex digital objects. We also are joined by Katrin, Hurlimann-Graham, and Elizabeth Hawkins from Queensland State Archives, speaking on some work they've done during the implementation of a new archival management system to introduce a representation model for metadata. And finally, we have Gattuso on work that National Library New Zealand is doing related to metadata, analysing content that had some validation failures and telling us all about some interesting metadata issues to resolve that have been revealed through this work. We'll have, some time for questions, discussion, at the end of the speakers. And then we're going to have a bit of time for informal networking. This is a time to, if you want to just chat and meet others in the community, it's very informal. There is literally no agenda. Tell us what you're having for lunch or tell us about a digital preservation challenge. Everything's on the table. It's a chance to get to know each other a little better. So that's it for the housekeeping. I think we will jump straight into Carey's presentation, which I am going to do. We're going to do this thing where I am the slide woman. Stand by.
Okay, so the title of my presentation today is Too Many Dates, the journey towards developing a unique identifier system. Next slide, thanks, Jay. So I came across this quote while completing the Digital Preservation Coalition's Novice to Know-How Access module just last week, and thought it summed up rather nicely the challenge we've been trying to address over the past few years at the National Archives. Back in 2017, we began a project to review our archival control model and develop a metadata schema for digital records. What started out as a seemingly straightforward task morphed into something much larger. While we agreed that our existing archival control model, the Commonwealth Record Series System, otherwise known as the CRS, was sound, our implementation of the record item had gone astray, being driven by our database system. This made developing a metadata schema for digital records difficult for a variety of reasons, which I'll look at next. Our primary archival management system is an in-house developed database called Record Search. Now, this database was designed primarily for paper-based records using a one-to-one data model where intellectual and technical metadata are captured together to describe the item. Even in the analog world, records often need to be copied or split for access or preservation reasons. such as the presence of hazardous material, fragile folios, or sensitive data. Solutions were created for particular instances, but then repurposed to deal with more complex issues they weren't designed for. Each item type, as shown on the previous slide, is given an identifier using a combination of the record series number, agency control symbol, and item ID, being a barcode. Barcodes were introduced in the 1990s as a form of intellectual and physical control. From a citation point of view, only the series and control symbol are used. Barcodes, though, have become the default unique identifier, often relied on heavily by staff to tell records apart. This becomes problematic when it holds a dual purpose for lending and location and can be applied through a variety of avenues, both automated and manual, resulting in issues of reuse and misapplication. It's not unheard of to open a fresh roll of barcodes only to discover that one has already been mysteriously assigned by someone else, potentially in another stage. And digitization projects and distributed custody agreements have also seen barcodes being reused or reapplied to an already described record. Adding digital records into this equation highlighted the gaps and issues with this approach even further. A primary example of how the functionality of our database drove description choices can be seen in the requirement to load digital surrogates for photographic records as individual images. Combine this with the functional issue that no images could be loaded to the database without a barcode, you end up with record units being split up in convoluted ways as shown on the slide to meet the database's requirements, but not that of archival control. Add to this that digital surrogates are not documented in the archival management system, but instead controlled loosely by titling them using the identifier of the analog source record, you hit another archival control issue. While the archival master is now being captured in the digital preservation system, it is loosely linked by the identifier, and the access derivatives are merely links in the public search engine held on a separate server with no metadata. Taking into account that there may be more than one archival master for photographic records, for example, a TIFF and a DNG, knowing which digital object you're working with is difficult and requires digging down into the technical metadata, relying on format and date information, which, as we know, may not be reliable. Add into the equation that the archives makes the decision as to the access status of a record, allowing for ongoing partial release. We now have to manage multiple digital access versions that the database system was not developed to do. In the analog world, redactions and masks are generally contained within the original paper record. Thus, the identifier doesn't change, only the access status of the record. In the digital world, new digital objects are created requiring their own management and thus identifiers. These need to be clearly distinguishable from the unredacted master to prevent inappropriate release. Having long had to deal with the issue of complex record structures and multiple manifestations, metadata for our audiovisual records has been managed in more dedicated systems. Issues arise, though, when trying to integrate that metadata with the primary system of record search, which still wants to apply more traditional practices for simple paper records. Intellectual metadata is concatenated to present a single item that may or may not have multiple physical and digital representations attached to it. This entry is then given a single item ID in record search, giving a somewhat false view of the record and often leading to issues with access. This issue has also flowed through to our capture of complex digital records, where a rich layer of metadata and digital objects are effectively hidden as we treat electronic record keeping systems like paper files. When transferring in our own EDRMS to the then digital archive, only the top folder was described in record search, and the digital objects were all given the same identifier as this record, often losing their original one. Work is currently underway to address some of these issues from a description point of view. So what I've shown you is just a sample of some of the issues that led us to rethink our approach to arrangement and description, refocusing our attention back to the record and not the system's functionality. The end result was a more flexible data model based on concepts taken from PREMIS, the international standard for digital preservation metadata, that separates the intellectual from the technical. We also drew extensively on the semantic units in PREMIS to inform our updated metadata schema. With recognition that the multiple representations and parts of complex records need to be managed in their own right, we now face the challenge of updating our unique identifier system to meet this. So what have we been doing? To start with, as part of work undertaken by the then Digital Archives Task Force to develop a metadata schema and submission information package structure for digital surrogates, we commissioned a report from Record Keeping Innovation to look at options for unique identifiers. This report was submitted to our Archival Control Model Committee, who developed a working group to review and identify gaps in the current system and provide recommendations for appropriate changes based on a set of criteria adapted from work out of the UK National Archives. The criteria that we used were that it must be unique within the relevant domain, which in our case includes not only the National Archives, but also potentially the Australian government, as records may be retained within agencies. It also needs to be immutable in that it does not contain properties that are subject to change over time, nor are implementation system specific or dependent. Computational, so they can be valid for use within a URI to enable persistence, and uniform, have a prescribed format that enables validation as an identifier. Identifiers may also be understandable, that is easily understood and conveyable by humans in that they are succinct and able to be transcribed and verbalized, and or knowledgeable, convey meaning provided that meaning is immutable. So the working group has just developed a set of 43 requirements for a proposed unique identifier system to cover all of the entities within our updated archival control model. So in this presentation, I've just looked at the record, but we also changed the agent, function, and relationship entities within our archival control model as well. And this slide provides a snapshot of some of the key requirements grouped by theme. So requirements have been written in terms of must or should to provide guidance in both developing the final format and the technical solution. From an intellectual perspective, the working group have aligned to all 5 criteria, making them generally a must. The critical issue will be meeting the requirement not to overlap with existing or previous identifiers, as I'll discuss a bit further under challenges. From a technical perspective, one of the driving forces behind this work is to enable interoperability and link data both internally and externally. The overall changes to the archival control model and the relational approach to the CRS system are designed to support this. Access again makes the nod to link data. What will be interesting is the issue regarding public referencing and citation and how much a desire to enable understanding and imply meaning will impact the final structure. Finally, key to all of this will be re-establishing a strong governance model to ensure our unique identifier system remains fit for purpose. While the requirements are excellent and quite comprehensive, from a personal point of view, I see some challenges for us going forward, including steering away from entrenched processes like asserting meaning and requiring them to be succinct and conveyable by humans. For example, staff are accustomed to alphanumeric series numbers like B2455, which they intuitively know are the World War I dossiers. However, that's not their series title. And while the alpha prefix B represents the state the records were first registered, being Victoria, it is often read as the current location, which is no longer valid, as over the past decade, we have moved large numbers of records interstate, including B245, which is now located in Canberra. Staff, though, still feel more comfortable with short identifiers they can verbalise and assign meaning to, often within a narrow context of their activities. Avoiding clashes with existing or previous systems will also be an issue, particularly as the preference is still for an alphanumeric solution that represents the various entity types. The alpha component is problematic as we have used single and double letter combinations quite extensively already for series numbers. Obvious choices have already been taken and solutions proposed struggle to provide a consistent and logical approach that is immutable. For example, AP for agent person clashes with series prefix AP, Adelaide permanent. While AO and AP are proposed for agent organisation and agent person, AO cannot be used again for agent other, resulting in the proposed alternative AR being inconsistent with the rule used for identifying the other 2 agent types. Deciding when to move away from the existing systems, how and which ones to leave in place are also posing challenges. It's agreed that the barcode system still needs to be used for managing paper-based records in our lending system. However, recently this was reconfigured as item ID on our public website, posing challenges now of moving away from it. We also now have to consider the other pre-existing identifier systems for agents and series. Do we want to overlay a new identifier over the top of these, as we want to do with the barcode, or do we just stop issuing these and replace with the new identifier system, retaining the old identifiers as searchable metadata? Where do we draw the line? How do we describe the old identifiers? How do we convert the item ID back to barcode without confusing both staff and researchers? My personal preferences have changed over time, and I'm more for assigning meaningless identifiers like those used in the archival resource key ARC model, which inspired the images on this slide, and rely more on assigning richer metadata to the entities so that meaning doesn't have to be asserted through the ID. That, of course, is possibly naive, as people will inevitably assign meaning somehow. I think, as the French National Library discovered, researchers were using their ARC identifiers to cite and link records out in the wild. So, as a final thought, I came across this image again while putting this presentation together and was struck by the final frame of the tyre swing, as I think it reflects somewhat how I feel, and that maybe we've been overthinking this when really we just need something quite simple. And that's it. Thanks, Jay.
Brilliant. Well done, Carey. Thank you so much for sharing that and for articulating those challenges so well and so honestly for us. Virtual round of applause. Thank you so much. What we'll do is, folks, if you have questions, please use the chat, throw them in there. We'll do the questions at the end. So in that case, I will stop sharing my screen and I will invite Katrin and Elizabeth from Queensland State Archives. Share your screen and it's over to you two.
Right, so I'm Katrin Hurlimann-Graham from Queensland State Archives, and yeah, it was interesting hearing this presentation just before us now, because we all face such similar problems in archives, and this one being that we had an archival management system, Archives One, that was totally set up to manage paper records, and the more we have to deal with different versions and different representations of records, it just wasn't set up to manage this at all, and especially thinking towards the future, managing digital records, it wasn't set up at all. So 12 months ago, as part of the, let me see if I can change this, there you go. As part of the Digital Archives Program Tranche 1, we've implemented Archive Space. And to do that, we worked with a consortium led by Gaia Resources. They configured Archive Space to our purposes. And yes, they did. Sorry. And the other members in the consortium were Hudson Malonglo, who actually designed Archive Space in the beginning, and Record Keeping Innovations. Part of the whole system is, so Archive Space is our archival management system. Then there's also a discovery layer for the public archive search, and Archives Gateway, which is a secure portal for agencies to access their records metadata, including records that are closed that can't be accessed through the public catalogue. Now, yeah, the issue that we faced is looking forward, how are we going to manage digital records and all the different representations that we have? And so we started rethinking our whole model. And also, I just got to burst the bubble here. There is no Tranche 2 to Digital Archives program yet. So we don't have funding yet for an actual digital archive. So it's all our play. We have the model now set up that we could manage digital records, but unfortunately, we can't really test it yet whether we set it up right. But in the meantime, it actually serves a whole bunch of other purposes. So I'll hand over to Elizabeth for this part.
Lovely. So probably the biggest decision we made, and it seems very similar to what NAA has done, was to introduce 3 new entities to the archival model. Now you can see there's the standard model. You have an agency that creates or is responsible for series of records, and the series made up of items and also child items or sub-items. We also had, and any information about legislation and function was embedded in the descriptive metadata. There wasn't a separate entity for those. We also had separate modules within Archives One that managed digital surrogates of physical records, It's what we call Image Queensland, and a microfilm module that managed the microfilm surrogates, naturally. So that kind of worked with the paper-based system, but as everybody's discovering, we need much more flexibility than that.
Okay.
Yes, please. So this is our new entity model, which is a heck of a lot more confusing, but really does work. So we've introduced representations as an entity distinct from items, so similar to what NAA is doing or has done. And we've also introduced mandates and functions as standalone entities that then link to agencies and series and to each other. We'll talk about them briefly later on. So as discussed, this model separates the intellectual description, so that's attached to the item, from the metadata required to manage the physical or digital thing. So which is the representation. And again, this is based on the premise model. So an item may have a physical, an original version. It might have a microfilm copy and a digital copy. It can also have sub-items or child items, which can themselves have representation. So the letter in the file, the photograph in the album. So basically each item has at least one representation, but it can have many. And each representation must be attached to an item. So on to the next one. So in this example, this is actually the inquest of Samuel Hofmeister, the swagman, as in once a jolly swagman. So in this example, the item has two physical representations. So there's the original record and there's a microfilm copy, and it has one digital representation because we've digitized that record. So users search for the item and then choose the representation that they need. We can also manage which representations display in archive search and what people can actually place an order for. So it's a simpler data model. The item record note, we no longer have to put all the data related to the physical thing, the technical, preservation, availability metadata, attach it to the item. It's the representation, not the item, that's transferred in, that we put on the shelves, the one we do conservation work on, the one we issue to the public or the agencies. So the intellectual item metadata is core and is stable over time. It rarely changes, where the data relevant to the representation can change or may change. So when we have a digital preservation system one day, we'll be able to use this entity model to manage digital and hybrid records, where one item can have, a number of different versions, each one of which can have a different representation. So that will hopefully make it easier. So the advantages of the system, it's much cleaner and clearer to have one archival entity that intellectually describes the various versions of records while providing flexibility to manage each version in a way that makes sense for that version. So each representation has its own availability status, which makes it clearer for the public which representations can be used. And we can also, as I said, not publish particular representations. So we're not going to publish the master microfilm version, for example, so that researchers only see the representations they're able to access or order. So everything's linked, it's clearly visible. It's easier once you're working within the data to rectify inconsistencies across items and representations, so that when you're working within the record. Of course, there are challenges. We initially thought we'd be able to stop using sub-items, child items. We haven't. We're probably using them more than ever. Largely because it's not currently possible to relate representations to each other. So we do make child items, again, the photograph in the album, the letter in the file, the knife in the inquest, and then create representations attached to that. Also, the more complex data structure means working at scale can be a little more challenging. So we export things to CSV and you get this lovely, big, huge spreadsheet. But that, of course, where you've got all the entities one after the other in rows, it can just get a little bit confusing. And then you add in child items and their representations, that makes it even more complex. But really, we've found it it's working. It's working really well. It's working well for our customers. I think it took them a little bit to get used to, but they seem to have embraced it quite nicely, which is really, really good. And it does mean we can manage the records so much better. So then the last little bit, I did. Yeah.
I was just going to add.
Oh, yeah,
I was just quickly going to add here. It's been actually quite an interesting exercise of how to come from have this theory of how something could work. So when we were working with record keeping innovation on this item model and thinking what could work best, and then now we've had almost 12 months to play with it and figure it out. And yeah, some things we anticipated, some not, and it's led to a lot of really interesting discussions on just questioning everything we do and how we do it and why we do it and why we put certain metadata in which places and all that kind of stuff. So it's been a really interesting exercise.
Yeah, so we did, in this whole process, we went back to Tintax as everybody else does, is the Australian series system the one to use? And, we decided, yes, it was. There isn't anything else that does what we need. But yeah, this model has been really, it's been interesting, lots of learnings, and people love the flexibility, I think. So, and just very quickly, I mentioned mandates and functions. We've also introduced these as entities. So mandates are largely legislation and regulations, and functions, well, we know functions. So basically this information used to be embedded in the metadata, which made it harder to manage and harder to find in the descriptive metadata. So now they're standalone entities, which you can then link to the agencies or the series. So it means we can manage the really complex and changing and time-bound relationships that, particularly in a MOG world, we're dealing with all the time. So we're finding that has worked quite well. Again, it has introduced some complexity, but we find it actually very useful, and it will improve discovery as we get more in there. Obviously, we haven't got many in right now, but we are working on that, and bit by bit we will be able to improve the discovery of our records for the public clients and also for the agency clients. And that's it.
Right. Well, kia ora everybody. My name is Gattuso, and I'm a digital preservation analyst over at the National Library of New Zealand. And today I'm going to talk to you a little bit about validation work that we're doing on some files, what we're finding, what's interesting about that, some possible mitigations, and some kind of open questions really that maybe you've got some thoughts on. So let's control my screen. So I'll just talk you through what we're doing, what we've done so far, where we've got to, and then we'll talk about this kind of validation problem that we have. So the problem that we're talking about here is what do we do with files that Jove, which is a file validation tool, indicates have validation errors. The screen there you can see is kind of a logical model of indicating approximately where this happens. So it's between deposit, and then we make these kind of validation calls on the way to permanent repository. Traditionally, historically, we've ignored them as errors. We were overwhelmed just because so many files kind of flag as a problem, and we didn't really know what to do with them. So we've sort of made a bit of a mission to work on these now and do something meaningful with them. We reckon that there's about 5% of our 20 million files. Jove has something to say about them. What we can't tell you right now is anything qualitative about what Jove is saying. So the process we're following, we've built this validation testing framework. It's a relatively generic beast, and it's designed to allow us to try and automate as much of this process as possible. So we can find and export files by format from Rosetta. We can run them through Jove in a relatively automated way and get an up-to-date kind of observation from Jove. And then we can do some semi-automated analysis of the Jove validation and kind of form up these cohorts. So these are a bunch of files that have a similar reported problem in Jove. We're tracking everything on a big master worksheet because there's multiple colleagues involved in this process. We're trying to build automated scripting to fix, so anything with a common problem, we're trying to make sure that the processes that we use are scalable and reusable. So if we can, we'll run the automated fix, and if we can't, we'll build a new one. And then we run the comparison test, and this really is kind of where the exciting, interesting stuff happens. We're, again, semi-automatically assessing those comparison results. And if we're comfortable that there's nothing kind of gone awry with our process, we can report on that both manually for the kind of detail work, and there's a lot of automated work that goes into providing other colleagues with the processing data that they need to kind of shuffle things along. We reflect those changes in Rosetta, and then we update the master worksheet. So it's Python script, and it kind of just tries to do as much as it can by itself with as minimal human input as possible. And the other trick that we're leveraging here is everything is system generated data. So any identifiers we're using all kind of are built up from sets and reports. So the big question for us is, how do we validate a treatment? And what do we mean by treatment as well? So let's say a file, I'll give you some examples, but let's say a file gets a Jove warning, and Jove is saying, hey, this file has got TIFF tags in the wrong order. What we're wanting to do is be able to, but what we need to be able to do is validate that that treatment hasn't changed anything other than that part of the file that we cared about. So historically and traditionally, we kind of deal with fixity as being the key token of file integrity with sub-object. So we're dealing with increasingly some typography and text. And I'll talk about some of these examples as we go through. So this is very much a work in progress. Most of this stuff just kind of happens on this laptop that I'm talking from. But increasingly, again, what we're looking to do is automate as much of this as we can and shuffle it off to something a bit more robust and battle hardened. So what you can see in front of you is a screenshot of some of the assets that I'm creating when we're doing an image treatment. So the cohort is of FMT353, which happens to be a generic TIFF file object. This is cohort number 4, and there are, it looks like six identifiers in that set. And we're looking into one of them, which is this particular TIFF file. We're generating lots of metadata with Jove, with XFTool. We're logging differences, and we're logging pretty much everything we can find along the way. So there's lots of metadata gets created, and we're kind of still pondering, what do we keep forever? What do we just use to validate that process amongst ourselves and our colleagues, and then kind of chuck away after we've committed that change. So this is kind of an interesting part of the problem for us. In the middle, we have an image from our collections. So not you people from Victoria, but most of you are welcome to come over to New Zealand for your next holiday at the moment. And on the one side, we've got the intellectual metadata that we store in the bibliographic record. And that's kind of managed by part of the organization, what I would describe as the intellectual or curatorial. And then on the other side, we've got the technical metadata. So this is data that we can pull out of that file using, that's come from XFTool. And so the question is kind of, who needs to tell whom about changes? Who are the kind of signing off person or entity? So here's an example of a technical change. On the before side of the image there, we can see XFTool is complaining that these tags are out of order. Unfortunately, I can't use the highlighter tool, but if you just kind of go down about 4 rows to X resolution, in blue, you can see that if you kind of know your hex numbering, numerically that's out of sequence. So we've got 0, 0, 0, 1, and then 1A, 1B, and then 0, 2. So TIFF expects per the spec, or Jove expects TIFFs per the spec to have these tags numerically sequenced. And we can use XFTool to reorder those without touching the image entity. And that's what we can see on the other side. So we've not touched the image object, we've not changed any metadata. What we've done here is simply kind of shuffle that metadata around and put it in the right order, and that stops Jove complaining. So that would be, for us, a pretty good result and an easy fix. This is another example. So in the before slide, you can see I've highlighted there a couple of bytes. We're viewing this now in a hex editor. And these are the date time separators in one of the fields. Incorrectly, a piece of software has set those to be full stops. And in the after slide, you can see that I've changed them to colons. Jove is happy. I'm happy that we've not changed anything in the image apart from those byte sequences. And one of the open questions for us is, what do we record? Do we record that we did this, or do we record the locations of the changes in the before and after state of those bytes? Here's another example, and we're going to go into this in a little bit more detail as well. This is a Jove, this is a PDF file that files Jove, and we're just now starting to rummage around in that particular format. Jove complained there was a problem, but we don't know what the problem was. It just kind of had an unexpected exception error. I opened that particular PDF file, opened it with Adobe Pro, and then saved it as another PDF file. And I tried to turn off as many of the automated things as we can. And it's notable to see that we've moved from version 1.4, PDF version 1.4 on the original, to version 1.3 on the fixed version. And even just this little bit of metadata at the bottom, the number of objects have changed by 3. We don't yet know what those objects are. There could be empty items within that PDF. And so the next stage for us is to try and figure out what's changed and is it relevant? And do we need to let somebody know, does it matter? And that's a really, really big question, particularly when we think about archival and evidentiary purpose of objects. So here's a kind of a bit of a deeper dive into some of the image-based comparison that we're doing. So this is comparison beyond fixity. We can do fixity comparisons at the byte level. You know, does this MD5 equal that MD5? That's pretty straightforward these days in most of the platforms that we can use. And in this kind of process, what we're doing is we're looking inside that, and we're looking at the image. So here you can see an example of one of those pages. So this was a 72-page PDF, the one I was referencing earlier. When I made that conversion, I can also use another tool just to turn all those PDF pages into a image file, and then I can compare them in the imaging domain. So what I'm trying to do is normalize as much of the object as I can into a reliable, predictable kind of format, and this is basically assessing things in image dimension. So those pages pretty much look the same to our humble human eyes. It's of note that in the conversion process, 72 pages, 64 of them had changes, and the remainder did not, which I find quite interesting. Just you know, interesting to think about what Adobe's doing under the hood there. So we've got these relatively complex products that we're producing, and they're all designed to try and illuminate where those differences are. So on the far side, we can see one called Diff. That's a pure difference image. So I've subtracted one from the other mathematically and turned it into an image. And I often use an inverted instance of the same object just to kind of see things a bit more clearly. Sometimes inverting the image just to see where things are. And on the other side, we can see this thing called a Diff Mask. This is a relatively new product. This is basically a summary of all of the pixels on that page that have had some kind of a change. We can't tell from this image how deep that change is, but we can see to the extent of that change. And it's useful, again, on this image, we can see that it's clearly parts of text and some small graphical items that have had a change. It's not uniform across the whole object. It's definitely confined to some kind of key areas. So we can look at those, that mask as a moving object. I won't go into the kind of gory technical details of what we're doing here, but we're looking at every pixel, progressively looking at deeper and more impactful differences. So when it's at its most obvious in the middle, and I'll loop around in just a second, that's one step change of difference, and that's where clearly most of the change happens, and there it is. And then as we get 2 or 3 steps and 4 and 5 and so on, we can see that those changes become less deep. Again, I've got the visuals on the left and right side, so we can compare them and see that they're mostly the same, but we can start to actually locate now where that changes and see that there does seem to be some change around that text. It's also notable that there are some pixels on this image representation of this PDF page. There are some pixels that are clearly part of the DCT process of the image. Here's a bit of a deep dive into what we're looking at. This is the logo of the magazine that appears on most pages, and it's actually what changes the most. And I know that this image is actually transparent, a transparent image item that's inside the PDF itself. So actually, I think what we're seeing here is the impact of of Adobe rendering that transparency out to try and make it a more stable object. And that results in slightly different instances of image compression, which when we zoom in, we can see not very clearly. You have to really look for them, but there is definitely some changes there that we can see. And if you have a look at those slides afterwards, you can kind of zoom in and check that out in more detail. And so the final product that we're creating is this one called, I'm just calling it a flipper. And basically all we do is we just get the original image and the treated image, and we just bounce to and from. And the idea here is to try and illuminate those changes as much as possible. So we can make some kind of a judgment call as to what we're doing, whether it's a change that's important, a change that we are comfortable with, or whether it's back to the drawing board and we have to find in the process. So those are the takeaway questions. The slides that I didn't think I would have time to, but I still have a couple of minutes that I will just mention briefly, are changes that we also see in the metadata that are intentional, but are a genuine change. So, for example, if we use XFTool to restructure the structure of a TIFF file, it also will go ahead and update the XMP history entity and will add another save step. And it might and it will change the last modified date, for example. So we have a question around what is the truthy version of what we've done? Does that metadata expect to live in the changed object because that's a truthful account of history? Are we allowed to privilege ourselves to an unaudited part of that file's history as a preservation treatment? Because clearly we are changing the file, but we don't want to reflect our changes on somebody's technical research on perhaps somebody else's process. We have open questions around how do we demonstrate these changes? What's the branching point for any changes that we've made? Are there things that the preservation layer can do without interrupting the curatorial layer? Or do we need to let them know about everything that we've done? And then also, what do we keep as an audit once we've done it? You know, does the future need to know what we did and why we did it? So there you go. That's my slide. Thank you very much. Thank you very much for your attention. That's all.
Thank you, Jay.
Thank you, Jay.
Virtual applause all around. Thank you so much, Jay, for persevering through those technical issues, which are inevitable in these times. Much appreciated. And thank you for such a detailed presentation. Love seeing those examples. And as you say, folks, you'll be able to have a look at the slides in more detail. And a perfect place to wrap up our official agenda, I would say. Please join me in thanking virtually all of our speakers once more. Carey, Katrin, Elizabeth, Jay, thank you so much for sharing your work. In a wrap-up scenario, I would say things like Leanne Raymond, one of our fabulous organisers, has volunteered to write a very short and sweet blog about what happened today. Look out for that on the forum and on the website when it's ready. On that note, I will quickly pop in the chat a link that you should all go and check out, because if you're interested in getting more involved in the community, keeping an eye out for speakers and people to share their work, go take a look at this link and get in touch with us. We'd love to have you on board, kind of shaping what this community is and does. It comes from all of you. We can't do this alone, any of us. So go take a look at the link. Consider if you can join us, even if it's only in a limited capacity. We're doing quarterly meetups this year, so the next officially organised one like this will be in August. Again, if you want to share your work, get in touch with us. It can be as informal or as formal as you like. So get in touch if you'd like to share your work for the August meetup. And I'm officially going to stick around for the next 15 minutes. If anyone would like to just join me, commiserate if you're from Melbourne, because I have not seen the press conference and I'm sure it was going on while we were meeting today. If you want to talk about challenges you're currently facing, if you want to continue the discussion we had today, stick around. We can stick around till about 12:30 today. But that is the official end. Thank you everybody for joining us. Again, thank you to all our speakers.